Okay, we're going to start by taking this ROM0 and ROM1 and inputting our values that we want to compute. We'll make this an 8, and we'll make ROM1 a 3, which those are the values in binary. And we want to make sure write is off and read is on so that the values are able to be sent up here to the processor. We're going to make sure that the accumulator out is turned off, just so that any value from here isn't making its way onto the data bus. And then address in, we're just going to select 1 so that ROM1, this data goes through onto the data bus, and we can see that the value of 3 is on it right now. This address bar right here lets us access any of these ROMs and any of the RAM to be able to write onto the RAM or be able to read from any of them. And then, so now that we have on the data bus value 3, which is 0011, it's making its way up here, entering the processor. We're going to make sure that it's going to B, since we're subtracting A from B. That's why we have our 3 going first. We're doing 8 minus 3, so we're going to store the B value before sending the A value in. And to do that, we will make sure this is set to 0. If it's set to 1, then it's going to send it up to the A value. To get it to the B value, we'll make sure this is 0. We're going to enable this register right here, which stores a value that's being put into it. And the last thing we have to do to put it inside the register is to clock it in once. And as we can see, a 3 pops up on this register and it's putting out 0011. And so now when we click enable B, turning it off, this data will be locked in here. And now we can change the address to 0, which is our ROM, so when we turn the address to 0, our ROM0 is activated and we're going to be reading from it, so that's good. And as we can see, this data 1000 gets onto the data bus 1000, and then that's making its way up here. It's right here, but as we can see, it's not going into the register since it's off, and we're going to want that to be our A value. And now that it's up here and the B value is down here, we can select different modes for our ALU. As you can see, we have add, subtract, and a couple others. And to select which one we want, we just toggle this right here. And as we do that, we can see it takes in our 8 and our 3. It does its own processes inside of it to give a different output based on what's selected. We'll just leave it on 0 since we do want to be subtracting our A value from our B value right here, so 8 minus 3. And then on the output side, we can see that this is a 5 in binary. And now we want to put this into this accumulator register right here. So we'll enable it and clock it in. And now we can go back, we can turn our enable accumulator off. And now with this off as well as this off, we can see that whenever we clock, this value isn't changing, and then this value isn't changing, or I'm sorry, this value isn't changing right here, since when these registers are disabled, the data inside of them that they give out does not change either. Next, we're going to set the accumulator out to 1, and it's giving us an error right now. This is because the address is set to ROM0 and we're reading from ROM0, and so that data is going onto the data bus as well as this output data coming from our accumulator register, giving us 2 different data values on the data bus, which can only hold 1 value at a time. To fix this, all we have to do is turn off read, and now this data isn't passing through anymore, and the data bus is holding our 5. Now we're going to turn write to 1, which activates parts of these RAMs down here, which can store or we can read from. And so we're going to be writing our 5 into RAM 6, which is currently a 0, as we can see. So we'll change the address to 6, which is 1, 1, 0 in binary. As we can see, this AND is met, and we have our 5 going down the data bus and entering it right here. All we have to do now is clock it in. You turn that off and then back on. And when we did that, this changed to a 5. Now, this is a digital machine since it only deals in binary values and not continuous ones. And these binary values are called bits. It's just a single binary value. They're usually contained in a string of multiple bits, as we can see in our ROMs right here. Or up here, we can see a couple of them. And then registers store this data, groups of data bits, as we can see. 4-bit registers are what we're using here. And this is just so that your data doesn't get lost while you're doing other computations. In this microprocessor, there's 5 registers. We have 3 for the RAM, and 1 for store B, and 1 for the accumulator. The accumulator is our output. We can save data here so that we can change stuff back here, and the number up here won't be affected. And then we have store B, which takes the first input that we want to do computations with and keeps it right here so that we can send it as well as the A data to the ALU at the same time. And then our registers down here can store past values that we write in from the data bus as well as be read from. And then when we did that, when we sent this data down here, that completed our computations. And now we can turn write off and then choose to read from whatever we want to compute further computations.